Welcome to Maths and Science by IITIAN channel. Now, in this lecture, I will be discussing a very important topic in number theory, a good problem. We have to find out the value of A such that for any integer n, the value of integer of n is not given. For any integer n to the power of 999 equivalent to n mod A. The value of n is not given here. Still we will get the value of A. For any integer we have called it. For any integer n to the power of 999 equivalent to n mod A. It's not an equation like linear equation where some values are given and you are asked to find out x. Here the condition is that for any integer, this is what is the problem that is subtly underlying in getting a solution for A. Now, what are the number theory theorems which we can use? What are the functions we can use where a particular value of n is not given and n is treated as any integer? Then, to solve this, we may have to use Fermat theorem, a powerful theorem in number theory, and Carmichael function. These two things are already discussed at length in various problems I have solved in my previous lectures. But still, I will give little bit of techniques, how to use them and how to solve this problem. Please try to understand, in this problem, n is an any integer, n value is not given, and we have to find the value of A. A will be an integer. Find the value of A, which is an integer. Now let us try to solve it. It's a very good problem. Please pay attention till the end and grasp the concepts about the Fermat theorem and also Carmichael function. And if this type of problems you come across, please solve them in this method. Now, let us move forward. What is the question given? Question is, find an integer A if n to the power of 999 equivalent n mod A for any integer n. This looks very simple at face value, but because integer value n is not given, hence it will become difficult to solve this. We will try to apply certain theorems and try to solve it. Please follow me. Solution. Here, let's recollect our knowledge about Fermat theorem. What Fermat theorem says? N to the power of p minus 1 is equivalent to n not n rather 1 mod P, where P is the prime. You please try to understand this. Where P is equal to prime number and P and N are co-prime to each other. This is the condition under which Fermat theorem is applicable. Are you finding some similarity in the problem given? What is the problem given? N to the power of 999 is equivalent to n mod A. But here it is not given that A is a prime. We cannot directly apply Fermat theorem. This implies it looks like n to the power of k equivalent n mod P, where P is the prime. But here A is not the prime. We are not told it is a prime. It is told that it is an integer. A is an integer. It was never told that A is a prime. N to the power of k equivalent n mod P. Let us combine these two. Fermat theorem, n to the power of p minus 1 equivalent 1 mod P. P and n are coprime and P is a prime. Now, this can be written as a to the power n to the power of k equivalent n mod P. Can we write like this? These two are equivalent. From these two, we get that P minus 1 divides k minus 1. You just see, here the power is p minus 1, here the power is k, and here it is 1, here remainder is n. But at both the places it is mod p and mod p. When you write n to the power of p minus 1 equivalent 1 mod p, n to the power of k equivalent n mod p, then p minus 1 should divide k minus 1. This is the equivalent meaning of Fermat theorem. From Fermat theorem, we got one condition is that Fermat theorem is n to the power of p minus 1 equivalent 1 mod p, which we have written as n to the power of k equivalent n mod p, with a condition that p minus 1 divides k minus 1. Fermat theorem is equivalently written this way. This is also Fermat theorem only. It is equivalently written. Now, what is given in the problem? N to the power of 999 is equivalent to n mod A. A is an integer. Here, if k is equal to 999, that implies we are comparing this and the given problem. Prime P, here it is a prime. Please understand, this prime is combined with A. P divides A. P divides A and P minus 1 divides k minus 1 implies P minus 1 divides 999 minus 1. That implies P minus 1 divides 998. What are the factors of where P is prime? Here P is equal to prime. What are the divisors of 998? Divisors of 998 are 1 is the divisor, 2 is the divisor, 499 is the divisor. Sorry, we will put the comma here. 1 comma 2 comma 499 comma 998, 4 divisors, because 998 is equal to 2 into 499. That implies P minus 1 is equal to 1, one possibility. P minus 1 is equal to 2, second possibility. P minus 1 is equal to 499, third possibility. P minus 1 is equal to 998. That means what are the possible values of P here? P is equal to 2, P is equal to 3, because 1 plus 1 is equal to 2, 2 plus 1 is equal to 3. P is equal to 499 plus 1 is 500 and P is equal to 999. There are various values of P, but from the assumption we have made, P from the Fermat theorem, P should be a prime. That means from the divisors of, from whatever we have got from Fermat theorem, from the divisors we can say that P is equal to 2 and P is equal to 3 are only valid entries we accept for P. as P is the prime. 500 is not the prime. 999 is also not a prime. Hence P should be 2 or P should be 3. Now, A is an integer. P divides A. A is an integer, and we found from the above discussion that P divides A. That implies 2 divides A, 3 divides A, because P should be either 2 or 3. If both P divides A means 2 divides A, 3 divides A. That implies 2 and 3 divides A. That implies 2, 3, 6. These 3 numbers divide A. Then, what will be the value of A? We have to find out what should be the value of A. Here, another most important consideration or most important thing we have to consider is that the integer A must be square free. Here we have applied Fermat theorem, we have applied Carmichael function, and we got the value that 2, 3 and 6 divide A, and A should be square free. For example, other than 2, 3, 6, if A has any other value, divisible by 2 and 3 and 6, 2 or 3 or 6, for example, A is equal to, let me say, 12. That will be 2 square into 3. This is not acceptable. This is not acceptable. Even though it is divisible by 2, divisible by 3, divisible by 6, but it has a square. A must be square free. Hence, the only possible values for A to B, the only possible values for A to B, we can take in addition to co-prime factors 2 and 3, we can take 1 also. 1, 2, 3 and 6. This is the answer. The largest value of A, is equal to 6. This is the answer. I think you got the concepts clear regarding application of Fermat's theorem, where we have applied the Fermat theorem and we got n to the power of p minus 1 equivalent 1 mod p. You just see. This we have converted to n to the power of k equivalent n mod p. This will be possible only if and only if p minus 1 divides k minus 1. This is what we have got from the Fermat theorem. And also from the problem given, A is not the prime number. N to the power of 999 equivalent n mod A. It is not told that it's a prime number, it's an integer. Hence, P divides A, because it is mod P here in the Fermat theorem. That is a prime. That prime divides A. When prime divides A, and when you apply these two theorems, then we get the value of 2 and 3 as the primes for P, and A is not a square. It is A integer must be square free. That's what we got from the second theorem. And when we combine all these concepts, we got the value that the largest value of A is 6 and other values are 1, 2 and 3. Total number of values are 1, 2, 3 and 6. This is the way we have to solve this type of problem. It is a typical problem. It is out of my intuition I got it. And please, if you could not understand this, please put it in the comments. I will reply to you. If you have understood it, please see it again and again if you have any doubts. And best of luck to everybody. It's a different type of approach to the problems, and I will be giving this type of problems and solving them so that your concepts for the subjects will be multiplied and the concepts will be clear. Thank you for listening to me. Thank you for viewing my lecture. If you feel there is a value addition to you because of this lecture, kindly hype this lecture and also kindly share this video and subscribe to my channel Maths and Science by IITIAN. Please try to find out what different types of problems you may come across. Why I am taking numerous problems and solving them and making the concepts clear, because application is more important rather than only knowing the subject. I am applying in each and every my lecture, I am applying the concepts and making you aware that these concepts can be used in this way. And this application is also very good, and please see that my video can be hyped, and also please see that it can be shared so that more and more people get benefited out of it. And please subscribe to my channel Maths and Science by IITIAN. Thank you for seeing my lecture. Thank you for listening to me. Best of luck to everybody. Thank you.